just about ready. Give me, I'll count you down beginning in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hi, my name's Laura Berman. This is Tools and Techniques for Collaborative Coding, a CS50 2017 seminar. A couple of caveats before we dive into the meat of it. I'm not an expert. I have worked at quality assurance in 2 different Boston area video game companies for the last 3 years since I graduated. If anyone doesn't know what that means, quality assurance testers test video games throughout the development process to find bugs and help the engineers reproduce them so that they can be fixed. Because of this, I've seen a few of the ways collaborative projects fall over and explode in interesting ways. And I'm familiar with a lot of the tools that people use to try and make those explosions a little less common and a little less catastrophic. What I say here won't apply to all sectors of the tech industry, or all game companies, or even reliably across the same company project to project. People develop their own techniques and cherry-pick tools to suit what they do and how they work best. Overall, this is going to be a broad overview of some concepts that I think might be useful to look into. I'm not going to teach you how to use specific version control software or how to run an agile Scrum project. The point is simply to expose you to some ideas you may not be familiar with that might help you as you move into collaborations on your final project or some of your own collaborations later on. The last caveat is that your mileage may vary. One of the most important parts of choosing a process for collaboration is striking a good balance between what I'll call process overhead, which is the amount of time and energy your team spends doing things like writing documentation, planning what you're going to do, anything that's not actual coding. I'm a strong believer in things like documentation, organization, and task management, but at the end of the day, if you're spending more time planning and wrestling with a complicated software, you may need to stand back, take a look at things, and identify what's helping and what's not. As exciting as all of this process is, it's not the be-all and end-all, and at the end of the day, you have to do what works. Diving into version control. Version control software is meant to help you keep track of files. It's file management, it's file upkeep. I'm most familiar with a program called Perforce, which I use at work. It runs on what's called a client-server model. That's what I'll be discussing here. Git, which you may be slightly more familiar with based on our homework submissions, uses something called a distributed model. Some of these specific visualizations won't apply, but the general ideas definitely will. If you want more information on Git specifically, Brian Yu gave an excellent seminar on the topic last year, and I encourage you to check it out. So some of the things that a good version control software will do. It'll help you track who made what changes, when, and why. It'll help you keep all team members updated with the latest work from all collaborators automatically, instead of sending you a file and saying, hey, I changed line 32 in this, which could be wrong, it could get lost. Instead, you have the latest updates from your team members at your fingertips. It allows you to lock files that shouldn't be worked on simultaneously, things like Excel files that can't be merged together. If you're working on text files or code that can be merged, it helps you do so, making sure that you keep everyone's changes when you're working simultaneously. You can create separate branches or copies of the project. This lets you do things like keep a stable branch for testing while you continue to experiment in another branch. You can also keep copies of versions you've released to help with something called version testing later on. If I've released version 3 of my application and I want to make sure that users are going to be able to upgrade to version 4 without causing loss of data or major issues, I'm going to want to do version testing. And so it's good to have a version 3 lying around. Lastly, and possibly most importantly, version control software allows you to undo your mistakes. You can revert to earlier versions when you've checked in accidental, unwanted, or buggy code. The core functionality of a version control program looks something like this. You have your central repository where all of your files are stored in a central server. This is the official central version of your program. Files that live here have all of the versions that have ever been created of that file stored in the repository. This is the core of why it works. When you want to make changes to a file, you go to the repository, you take the file you want, and you check it out. Then you can make your edits in something called a workspace. This is a local copy of all of the files in the repository that lives on your machine. When you make edits here, you can see the effects, and you can run code or test builds, but other people on your project won't be affected by the changes you make in your workspace until you check it back in. When you check it back in, a new version of the file is stored in the repository with your edits. Then, after you've checked in, and the new file is in the repository, anyone who gets latest, who updates their local workspace to match the repository, will automatically have the changes that you put in. These changes are tracked in something called a change list. Change lists include a lot of automatic information, like the date and time that you submitted a change, the older version of the file and what was changed, your name as the submitter. You may include a reviewer, someone who checked over your code during the check-in process. This is a great habit to get into of before you commit your code to the version control repository. You want to make sure that someone else who's familiar with the project overall has looked over your code and made sure that they think it'll work, they think it won't damage the existing code base or interface incorrectly with anything that already exists. You also want to add notes about what changed and why. Change lists improve accountability, help track what's in a build and what isn't, and allow for version testing to ensure players on current version will be compatible after update. Most importantly, you can revert to specific prior CLs. Changelist 123 includes all of the changes that have been made up until that point in the exact form that they were at this time. So if I test build 123 and it works just fine, but later on in a couple of days, someone makes a change somewhere, we're not sure where, and it breaks something, we can roll back to changelist 123 that we knew worked, and then build from there, checking in piece by piece and testing, so that we can isolate the problematic code. Additionally, it can help you deal with some conflicts that might occur. If you were working without a version control repository or with one that didn't have merge functionality, you might both take a file in its current format and edit it at the same time. So let's say you've added the word bar, I've added the word foo, you check in first. Now the file plus bar lives in the repository or lives in some email somewhere. If I then check in, or if I then present my code as the latest revision, it's going to have foo in it, but it won't have bar. A good version control software will have a merge functionality. So after you've checked in, if I try to check in on top of it, it'll say, hold on, you need to resolve these changes. You need to make sure to choose which new things you want, which things you don't, so that we can be sure that at the end of the day, the file that gets stored in the repository has everyone's changes exactly where they need to be. So, what does that mean for you and your final project? Explore free tools that are available. If you find tools like Git or Perforce overwhelming, that's fine. They're very heavy duty for a small project, but they're not all that's out there. Even Google Drive has some version control functionality built in. I actually took this screenshot while I was making this project. You can see it tracked some older versions of this presentation. You can name versions, you can roll back to them. Not very useful for a slide presentation, but potentially very useful if you want to isolate bits of changed code over time. It also includes who made changes when you work collaboratively. So that's a great lightweight version control that you can use right out of the box. If you decide not to use version control, you can cheat a little by saving often. Whenever you run your code and it tests successfully, no matter what unfinished state it's in, save it, name it version 1, and keep a local copy. So every time you delete something accidentally, or you forget what you had been trying before after you're experimenting with something new, you can go back, find code that worked, and make sure you always have that cushion to fall back on so that nothing ever explodes. You can't unexplode. So that's version control, a very fast introduction. Again, if you're looking for more information, go ahead and Google things like Perforce and Git. Go ahead and Google some of the free options that are available. And again, look into Brian Yu's seminar on Git last year. Methodologies. These are some overarching concepts that guide software development, guide the way that people think about approaching tasks, and how they divide up work in a way that makes sense and makes use of people's time efficiently. Companies I've worked for have mostly used Agile or Scrum development, so I'm most familiar with Agile methodology. It's currently quite popular, but it's not the only choice. I'll present a few of the others I've encountered as a jumping off point for further consideration and research. This is an old version of the project.
Do you need the other slides?
I think this doesn't have the last section in it.
Oh.
I'm sorry. I'm so sorry. I think that this didn't update because I'm not connected to the internet. I'm so sorry.
No worries.
That's why you do this as a recording.
Oh, I'm so embarrassed.
No, that's just fine. What's the Office Pass? Office Pass seems to be.
Alright, so it's an I. So would you like to use my laptop, or that's...
Sure. I'm so sorry about this.
No, no worries, no worries.
I knew I was going to be problematic.
No, this is totally fine.
I'm sure there's been much worse.
Yeah, it's no worries at all. You can try logging into your account there. This is totally fine. This is why we do post-production.
Yeah, there's all of this many people are gonna see it, so see this part.
Yeah, we're totally fine.
Oh, your Wi-Fi connected too on your thing if you just want to do that.
It works. Sometimes it might authenticate and...
Yep, it's got that slide. It's got that slide. So this is working
It's
now.
working? Alright, perfect. And
Thank you.
we'll get rid of this
Appreciate it. I
Yeah.
appreciate it. I'm sorry.
Do you want to add the what to Google talk? You sort of talked over it, but if you wanted to.
I'm just gonna go to the.
Go through methodologies.
Yeah, I'm just
Yeah.
gonna go for methodologies.
Alright, I'll just count you in over there again. You take a deep breath, we're fine.
Some water. Have a chill pill.
Okay, how about in 5, 4, 3, 2, 1?
So methodologies. Methodologies are a more conceptual way of thinking about how you divide up work on collaborative coding projects, how you manage what order things are done, and just the way you think about getting from point A to point B. Companies I've worked for have mostly used something called Agile or Scrum development. That means I'm most familiar with those methodologies. Agile is currently quite popular, but it isn't the only choice. I'll present a few of the ones I've encountered as a jumping off point for further consideration and research. Once you take a look at some of these on Google, you'll find it's quite a rabbit hole. So I'm going to point toward a couple of areas you might want to focus on if you think about trying a more formal methodology for organizing your final project. You might have seen this meme before. It's a little old at this point, but I think it still rings true. You can only choose 2 of these when you're in college: good grades, a social life, or enough sleep. Hopefully that's not true, but if it is, it may help you understand there is a similar idea in project management. Scope is the complexity of the project. How many features does it have? How difficult are they to implement? Are you reinventing the wheel or leveraging existing technology? Resources on something like a final project are a bit abstract. You could think of it as the number of people you have working on the project, the amount of time they have per day, the tools you have access to, that sort of thing. In a business setting, resources is much more concrete. Human hours, tools, training, facilities. I could cross this out and just write money. It's all money. And lastly, time, the all-important deadline. You can only pick 2 of these, and you have to be flexible on one. If I want 100 features and I'm the only programmer working on a project, you better bet I cannot set myself a firm deadline. That's going to take forever. If I want a firm deadline and I'm still only working with me, I'm going to have to make a lot of sacrifices on the scope of my code. I'm going to have to cut some things from my feature list in order to get things done in time. If I want all 100 features and that firm deadline, there's only one thing for it: I need more people. Methodologies are a way of trying to maximize the size of that triangle. Traditionally, the classic example of a methodology is waterfall or phase-driven development. This is very linear, very easy to track and understand. You write pseudocode for the P set. You convert your pseudocode into functioning code. If it doesn't translate correctly, you modify your pseudocode and try again. You test your code using check 50. If it doesn't work, you go back and modify your implementation and try again. There's no maintenance aspect to our P sets because we're not providing software as a service, so you're done. You get the requirements and you move straight through to the finished product. For simple single-person projects, this is really the only format that makes any sense at all. You can't test something before you've created it. You can't create it before you know what it is. But for multi-person projects, there are a lot of ways that this falls apart. Imagine that you're working at a 5-person company. You have 2 designers, 2 engineers, and 1 tester. Your designers sit down and they come up with a design document. They make sure it's functional and going to produce the product that they want to see, and they hand it to your engineers and walk away. Their time on this project is done, and probably they're off doing something else while your implementers are making it into a functioning piece of code. If they find something wrong with that documentation, they can't go back to the designers. They have to keep moving forward or try and figure out a way to morph it to be within the expectations and the requirements. Because the designers are already off doing something else, and pulling them back is difficult and expensive sometimes. The same with QA. By the time you get down to verification, the engineers are gone. You may have a QA engineer at that point who's responsible for bug fixing, but that can get really burdensome really fast. And at that point, there's no way to incorporate learnings from your testers into the design of the project. So the larger this gets, the more problematic waterfall becomes. That brings us to Agile. Agile is generally considered the opposite or response to waterfall. Agile methodology does away with a lot of the upfront work on design and documentation. It focuses on getting the code working as early as possible and building stable features on top of it, releasing at regular time intervals. The scope of the project is flexible. At the end of every time interval, you ideally have something that is good enough. You could send it out and it would be okay. Agile methodologies also build in the assumption that requirements will change, things will go wrong, and the path to a completed project won't be perfectly linear. It allows for things like bug fixing, usability research, and user testing to happen throughout the entire project. Ultimately, you're trying to maximize the efficient use of your resources. You're breaking down your scope into achievable chunks, and you begin to get a better estimate of what can honestly be accomplished in a given amount of time to make sure you're getting the largest, most efficient triangle possible. it's scalable, it's iterative. Another ideal of Agile is self-examination. At regular intervals, the team participates in something called a retrospective, when they sit down and think about the process itself. What works, what doesn't work, how things can move forward more efficiently. Do you even like using Scrum? Would you rather be using a different methodology? Would waterfall make more sense? Agile includes that question in itself. The next few slides are subsets of Agile, functional methods of getting closer to this ideal of a flexible project that makes good use of multiple contributors' time and responds to setbacks efficiently. Kanban is the Japanese word for card. In Kanban, tasks are written out on cards, either physical or digital. Classically, it is literally done with a whiteboard and some sticky notes. These cards are prioritized top to bottom in a stack called the backlog. They're assigned out and tracked in something called swim lanes. Each of these is a swim lane. The ideal is to have as few tasks as possible in progress at any one time. You're trying to keep things dynamic. You don't want things stagnating or getting stuck. Timing is flexible. Unlike some other versions of Agile, there is no time boxing or regular planning meetings. Kaizen-style meetings focus on identifying and removing obstacles to the completion of individual cards. If something is sticking around in the to-do column longer than it should, you might call a Kaizen meeting only with the people involved in that card to move it across the board more efficiently. Kanban is very lightweight, it's very flexible, and there's not a lot of process overhead. Scrum, on the other hand, has quite a bit of process overhead. It's one of the most popular Agile methodologies, and it's quite a bit more complicated than Kanban. In Scrum, time is boxed into increments called sprints, usually about 2 to 4 weeks, depending on how big your project is, what cadence you prefer to work at. The goal is always to have a functioning, shippable piece of software at the end of each sprint. At the start of the sprint, the whole team gets together and takes stories from the product backlog. Like Kanban, this is essentially just a stack of sticky notes. It's the things you need to get done before your project is complete. You take the top priority items from that backlog, you sit down in a sprint planning meeting and you say, I think I can get 3 of these done in the next 2 weeks. You commit them to the sprint backlog. Then for the next 2 weeks, you work through those as quickly and efficiently as you can. And at the end of the day, you want to have a shippable product. The biggest benefit of all of this extra planning is velocity. When you're in the sprint planning meeting and you're saying, I think I can get 3 of these done, you're assigning each item a numerical point value. How big is the problem? Not just how long will it take you, but how complicated is it? How much potential for halo, is this going to break things that other people have already made? How complicated is it? Do we know everything about it? It's very personal to each team. But over time, after 3 or 4 or 5 sprints, you start to get a very good idea of not only what the points mean for your team, but also how many points you can typically get done in a sprint. This is one of the ways to actually understand the relation of time to Agile development and make plans for deadlines, even though you're working on this sliding iterative scale. A Scrum team has 2 different leadership roles. First is the product owner, who's very much the traditional leadership role, responsible for creating and prioritizing the stories in that backlog. They guide the direction of the project and handle the business end of the project. The Scrum Master, on the other hand, is team-focused. They're a coach and facilitator. They're responsible for getting things out of your way, making sure that you have everything you need to succeed, interfacing between developers. They're also responsible for some of these ceremonies of Scrum, which is an official term that applies to Scrum. Planning and point costing meetings, like we discussed. The daily stand-up is one to pay special attention to. It's a short meeting. Depending on how many team members you have, it could be 30 seconds. You stand up in a circle and you say, here's what I did yesterday. Here's what I'm going to do today, and here's what's blocking me on any of my tasks. And the Scrum Master's job is then to take anyone who brought up a blocker aside and make sure that that blocker moves forward. If they're waiting on work from someone else, maybe they can reprioritize things. If you're waiting on a tool, maybe they can get it for you. The daily stand-up is one of the fastest ways to increase accountability and understanding of project status for almost no process overhead cost. The sprint review happens at the end of the sprint. It's going over what tasks were successfully completed and what weren't. It's a chance for examination of point values. Did you overcommit? Did you undercommit? As well as sort of a victory lap for the team. They usually involve slideshows of all the cool things everyone's made that sprint. The retrospective is that self-examination meeting we were talking about. What worked this sprint? What didn't? What problems did we run into? How can we make things move forward more efficiently? So what does this mean for you? Obviously, a small group working together for a few weeks isn't going to benefit very much from a full-on Scrum team organization. Things like velocity and retrospectives won't mean much to you after a few weeks of working with 3 people. But there are a few takeaways that I think any collaborative project could benefit from, no matter how small. Try to think about your project in terms of small, achievable pieces. Stories, or whatever term works for you. Figure out the minimum viable product that you can get working as fast as possible, the absolute bare bones minimum that you need in order to consider your project a success. Be very critical of your assumptions on the project. Usually you don't need as many features as you think you do going in. Then plan out things that you can do on top of that, polish tasks or stretch tasks that can improve the project, make it more usable. Try to think about dependencies. Which things can you do at the same time, and which things have to be done one after another? You're trying to make sure that everyone on the team has enough time to do everything they need by trying to make sure you're all moving forward at any given time. If you're opening an ice cream shop, then I could build you an ice cream machine while you're building the shop, but installing it can't happen until both the machine and the shop are done. If you plan ahead well, everyone on the project can be working consistently from the start. If you want to try some of these for yourself to help organize your project and move forward, a couple of the better lightweight ones. The Kanban board is great. It's simple, intuitive, and low overhead. All you need is a wall and some sticky notes. Try a 4 swim lane board, I usually recommend. You want to do, in progress, ready for testing, and done. Having ready for testing in there makes sure that there's a conscious attempt to test every single piece of the project as it goes in. That's going to result in a much saner, better, stable product at the end. Try appointing a Scrum Master in your group whose job is to keep everyone else motivated, on track, and unblocked. It's great to just have that be someone's responsibility, especially if there's someone on the team that thinks it might be a good use of their time personally, if there's someone who feels drawn to that sort of thing. You can't always count on everyone to step up and take those sorts of responsibilities, but if you name someone, it'll help things go a lot more smoothly. Daily stand-ups are also a very easy way to keep everyone in a project accountable and updated on daily progress. You don't even have to be in the same room. Just agree that every day at noon you're going to go into the same chat room or send each other an email saying what you did yesterday, what you're planning to do today, and if anything is blocking you. If you need something from a teammate before you can move on with your own work, don't just assume they know. Tell them every single day at noon in a stand-up. Here are some things you might think about Googling. The agile software development in general is a great thing to look into. There are other subsets of agile that I haven't mentioned, things like extreme programming, things like, anyway. The Scrum Alliance is one of the better official sites to go to for information on Scrum. And there are some free Kanban board tools out there. If you don't want a physical wall or you're not working in the same place as your teammates, you can set up a virtual Kanban board. And this smartsheet.com is a great resource just comparing them all. I used it while I was making this presentation. It's very thorough. Talking about documentation. What do you do if you pull up to this intersection and you have a series of directions and all the directions say is turn left? There are a lot of formats that design documents take, and what works best is going to depend on the shape of your project, but there are some core principles that I think are really important. Design documents answer the question, what are we going to make, how are we going to make it, and why? The first two are easy enough, and most people are going to have to do some amount of it in order to get a collaboration going. The last one is really the important one that gets overlooked sometimes. When you get down to the actual implementation, you have to assume everything is going to fall apart. If there's one thing that you take from this talk, assume, in general, that once you come in contact with it, everything falls apart. You won't be able to anticipate every technical challenge right off the bat, and things will have to change on the fly. If all you have in hand is a design doc that says turn left, you're at the roundabout with your GPS screaming at you, and you don't know where to go. You need the why to be able to find another better way to the destination, to get through the roundabout and figure out you wanted Maple Street. Documentation isn't just something that happens when you start developing a new project or feature. You want to write a draft with more detail than you think you need. Send that draft around for review to every team member. On a smaller final project, this is easy, but it gets overlooked on larger projects that have contributors like quality assurance and design and engineering and server engineering. A server engineer might come back after reviewing the design doc and say, this implementation is extremely inefficient. Why would you do it that way? QA may come back and tell you, you can do this, but it's going to take 6 solid weeks to test. The business manager may come back and say, yeah, but how is it going to make us money? You may come back after sleeping on it and say to yourself, it could be more elegant, or you could solve a problem in a better way. You want to sleep on it for a day and send it again after revising just to make sure. During implementation, if you find out that you need to take an alternate route, update the documentation. A design doc is a living document. It needs to be accessible to everyone on your team and updated as frequently as possible. Otherwise, the person who comes after you won't know what they're building on. Your testers won't know what to test. Your bosses will wonder why the feature doesn't look the way they thought it was going to look, and get mad at you. You will be lost. Lost. Was that melodramatic enough? I think design documentation is incredibly important. Google Drive is a great way to maintain design documentation, by the way. The built-in comments, the accessibility. Keep it in a central location where everyone can always access it, make comments, and revise it as needed. It's going to save you a lot of heartache. User stories. User stories are a sort of Scrum-associated way of thinking about documentation and designing. When blank, I want to blank so I can blank. You're putting yourself in the shoes of a user and saying why you want to interact with a piece of software in the way you want. Let's say that a grocery store is a piece of software. I'm a typical user and my arms are not very strong. I enter the store knowing I will probably need more items than I can carry. I want to take a shopping cart so that I can collect and hold everything I need to buy without getting tired or dropping vegetables everywhere. That is my user story for the shopping cart feature. When I go to the store, I want a shopping cart so I can carry my food. The user story is a very simple, elegant way to think about every single piece of your project in detail. It's also a good time to examine some of your assumptions. Remember, we talked about minimum viable product. Maybe a shopping cart isn't the correct answer for my minimum viable product. Is it really the best tool to get me from my situation to my desired outcome? Maybe a basket would be easier to implement and be just as functional for most users. You could always come back and implement shopping carts later for people who are throwing dinner parties or shopping for the whole week at once. You write 2 user stories and you put the shopping carts lower down in your backlog. If you have time later on, you get to it and you make your software that much more functional. User stories also need something called acceptance criteria. a checklist of criteria that must be fulfilled before the task is considered done. Done is a very important concept for you to sit down and think about. What is success? Where are we going? The shopping basket, for instance, is done when it holds, about 15 items. I can get one, I can return it when I'm done, I can put things into it, I can take things out of it. Otherwise, it's not a shopping basket. There are a couple of things that would make a shopping basket better, but they're not part of that minimum viable product. Your polish and stretch goals should be thought about early on, but you need to be honest with yourself about what is essential and what is not. I might want ergonomic handles to make carrying the basket easier. I should have put this one higher up on priority because it should be. You want the baskets to be accessible to lots of different kinds of users. So making them able to be attached to scooters or compatible in some other way with assistive devices. You want to be able to stack them and remove them more efficiently so that when your workers are rounding them up, they don't spend as much time and resources fiddling with them. That sort of thing is a polish or stretch goal. What does that mean for you? Write documentation. Yes, you. Write it. Do it. Are you already writing documentation? Write it better. The number one difference I've seen between effective teams and teams that duplicate work or forget tasks, write a lot of bugs, and get mad at each other all the time is clear, detailed, frequently updated, centralized documentation that was reviewed before it was implemented. It makes teammates happy, it makes testers happy, it makes producers happy, it makes users happy. Is it a pain? Kind of. It's process overhead. You know what's more of a pain? Trying to assemble your final project only to realize that the code you wrote doesn't interface correctly with the team's main function, and you have to frantically churn out new code the night before the project is due. Some things to Google. There are templates out there for software design documents that can make the process of understanding what to write a little bit easier. User stories are also something that there is a lot of opinions floating around about. You'll also see some people who don't like user stories. I think they're useful, but it's really up to you to decide what works best for you. Just do write documentation. It is important. And testing. This one is near and dear to my heart as a QA tester. This is a screenshot of my favorite bug. Once, in a game I worked on, there was an issue with asset bundles that didn't appear in the game's editor, so the engineers and designers weren't aware it was happening. It only appeared once you built the game, uploaded it to the server, and got it onto a testing device. We used iPads, that sort of thing. Every 2D image in the game was smearing itself across the screen like a kaleidoscope. Swirling, scrambled up text and images were everywhere. This little matrix of item art down in the corner was spinning where the loading bar is supposed to be. When this happened, we couldn't test anything for 2 days. There are a couple of ways to think about how bad a bug really is. The kaleidoscope bug was a critical always blocker, meaning its impact on gameplay was enormous. It reproduced reliably every time we followed the STR, opening the game. And it blocked gameplay, meaning it prevented us from doing necessary work or made a portion of game content totally inaccessible. It had the highest possible user pain score. Severity, frequency, whether or not something is a blocker, what you call blockers, user pain, all of that varies from company to company, from project to project. But it is a good way to think about what it means to be a bug and how to prioritize your bugs. When writing a bug, you also need to be very careful to explain it clearly. The PB&J sandwich example that from lecture 1 is actually a question I used to ask in interviews because it's very, very important to be able to explain the steps to do something as clearly as possible so that when you hand tests back to the engineer who's going to fix them, they know exactly how to reproduce them and they can isolate where it's happening in code. Again, this sort of thing becomes less important when you're not passing things off to dedicated QA testers, but it is a good thing to start thinking about. What does this mean for you? Your code is broken. Believe me. Trust me. I know. No matter how cautious you've been, give an experienced QA tester an hour or two and they will find some combination of inputs that causes your program to explode in hilarious and horrifying ways. If you assume this and leave plenty of time for testing and bug fixing, you will live a happier and longer life. Edge cases are very important. We've been somewhat spoiled in this regard with Check 50 since it automates common edge case testing for us. What happens if you ask the user for a number to input and they give you -8 or 400 trillion or cheese? The most dangerous part of any code is when two pieces rub up against each other at the edges. If an MMO runs a special event that enchants armor, and at the same time elsewhere in the game a different developer has implemented a new raid, you'll probably catch major issues with the armor's stats or functionality or with the raid boss before you release them. The danger is when you put on the armor, enter the raid boss spits fire on you, and the fire effect doesn't know how to handle the special damage modifier on the armor, so the raid boss's logic falls out of an essential loop. Now the raid boss, the big scary raid boss, is standing there flapping and staring at you and doing nothing until you either rage quit or the instance times out. Everything is magenta and nothing is happening. No matter what, whether you're doing a solo project or a group, I believe you always need 3 essential people to test your code before you call it done. You. Test your code as vigorously as you possibly can, then do it again. Someone who has read and understands your code should also be testing. If you have teammates, this should be one of them. Someone who can identify things that coders know about, like overflow, and remind you to test for those things, test for them themselves. And 3, a completely random person. Never underestimate the destructive inventiveness of random users. Tell this person nothing, just hand them the program and let them go to town. They will find bugs, and it will be to your benefit to fix them. And finally, remember the scope triangle? It is not your friend. On this project, you have very limited, very firm deadline, and you have a maximum amount of resources that you are allowed to make use of. And as your resources increase, the required scope also increases. Remember, you have to do more work if you're bringing more people into this project. The only thing you can be flexible on is scope, and believe me when I say it's so difficult to scope a project correctly at the outset. You're going to run out of time, and when that happens, there may be things in your code that you're aware of that just don't work. If they're not essential to the function of your code, especially if they're in polish features, don't hide them. Known issues are an important part of transparency and help people understand how to use your program well. They also are a learning moment for you, and later on you can come back and try and see what could have gone better, how you could have prevented those issues. Some things to Google. There are some free bug tracking software out there. The software I mostly use in my work to track bugs is Atlassian Jira. I believe it is proprietary, but they may have a free trial. At any rate, it's worthwhile looking at their specifications to see what sort of things are useful in a bug tracking software and what sort of things might be useful to you. User pain, as I said, there are a lot of different ways to think about severity and frequency and user pain. Formulas that are out there that may be useful for understanding what a bug is, understanding how the industry thinks about bugs, and how you should be sort of preparing yourself to work with other people. So that was testing. That was tools and techniques for collaborative coding. My name is Laura Berman, and thank you for watching.